Swayam Prabha. Digital India. Educated India.
Okay, let me take few more problems on this earth pressure, and I have done already 6 problems to show different variations, active, passive, at rest, sloping surface, then layering only between cohesionless soil, the cohesionless soil, cohesive soil, all those things taken, and few more I will take. So, let me take the first one here. The problem is like this: a retaining wall 4 meter supports a backfill with a horizontal top. The wall is pushed towards the fill. Compute the total force acting on the wall. The properties of the fill are C equal to 25, phi equal to 20, gamma equal to 18 kilonewton per meter cube. So, here so far so many 6 problems I have taken. I have taken only one problem on at rest, because at rest condition is most of the time is not essential. While designing you do either active or passive, and I have rest of the 5 problems I have done active, and again for different types Coulomb, Rankine and all we have done, but I have not taken so far any problem on passive, and we have told that clearly that both active and passive and at rest 3 different types of pressure distribution is possible, and when a passive will be there when the wall is pushing towards the backfill. So, here the problem is given that the wall is pushed toward the fill. So, that means this is a example of your passive case, and this passive case we have taken, and here actually surprisingly most of the time retaining wall will have granular fill, but here it is a partly granular, partly cohesive. You can see the soil is having both C and phi, and when soil possesses both C and phi, then the earth pressure will be different, which already we have discussed. I have taken one problem, partly we have applied there. Here actually is a purely entire depth is cohesive soil or C phi soil, and then for that, and this is a passive case, and for this what is the thrust will be on the wall, that to be determined. So, let us try to solve this one. This is of course a quite simple one, and you can see the wall height was how much, I think 4 meter high. So, wall was 4 meter height. So, this is 4 meter and it has level, and C equal to 25, phi equal to 20 and gamma equal to 18. So, it will have since we are going to apply the passive case. So, I have to find out now Kp equal to what, 1 plus sin phi by 1 minus sin phi. So, it will be 1 plus sin 20 divided by 1 minus sin 20. So, this will be the value will be 2.04. 2.04, Kp is 2.04, and as per the C phi soil, earth pressure diagram or Pp expression will be sigma 1 Kp plus 2C root Kp. This is the formula perhaps we have done, and so at H equal to 0, sigma 1 equal to 0, then Pp1 will be equal to or Pp 0, suppose will be, so this portion becomes 0. So, it will be 2I C multiplied by root Kp at a 2.04. So, that value is 71.41, and at h equal to 4 meter. So, sigma 1 will be equal to 4 into 18 equal to 72. So, P at 4 meter will be equal to 72 multiplied by 2.04 plus 2 into 25 multiplied by under root 2.04. So, this is giving you value 218.29. 218.29. So, the value, if I draw the pressure diagram from the wall. So, this is the one wall depth. So, initially we had a pressure equal to 71.41, and at the base we have got a pressure equal to 218. So, this is actually 218.29. So, this diagram area, if I find out, then it will be thrust will be acting somewhere here. So, it is a trapezoidal area. One can, if I know the centroid of trapezoid, etc., and other thing, then we can find out directly. Otherwise, for simplicity, I can divide it into two parts, that will be 1 and this will be 2. So, I can find out P 1 will be equal to 71.41 into 4, that will be equal to 285.64, and P 2 will be equal to half multiplied by 4 multiplied by 146.88. So, how to find out this 120? This is actually 218.29 minus 71.41. So, from here I am getting this one. So, this if I P 2 if I get, then it is giving you 293.76, and then your P p will be equal to this together 285.64 plus 293.76. So, this gives you 579.4 kilonewton. And now to find out y bar, this is suppose y bar, I can find out y1. So, y1 is for this. Okay, so, this is y1 and this is y2. So, this height is y2, middle of the. So, y1 will be 1/3 of 4 meter, because entire triangle I am considering, and y2 equal to half of entire. So, 2 meter. So, P p into, or I can say directly 579.4 multiplied by y bar equal to 285.64 multiplied by 4 by 3 plus 293.76 multiplied by 2, and if I simplify this, we will get the y bar equal to 1.66. So, this is the problem for passive pressure application. We have just you can see here, and so then how to do the passive pressure diagram and how to find out the thrust, how to find the point of application. So, this is shown. So, let me go to one more problem. This is suppose determine the maximum unsupported depth of a vertical cut in natural soil deposit with cohesion of 30 kPa angle of internal friction of 20 degrees and unit weight is 18 kilonewton. So, this is the problem. We have discussed the theory that when it is a active case, your PA expression for PA equal to sigma 1 Ka minus 2 C root Ka. When sigma 1 equal to 0, when sigma 1 equal to 0, which is at the surface, that means at the surface we have negative pressure. So, negative pressure means it will be a tension, that means because of this lateral pressure there will separation will take place, and when second separated place, if it is not supported, then it will collapse. So, during excavation that actually happens. So, if you exceed certain depth of excavation, because of this mechanism the soil will fail automatically. So, your pressure diagram generally comes like this, which I have discussed during theory part, this one, and you can see this much is negative, and at some depth it become negative 0 pressure, there is no pressure. But up to this depth definitely we can without support we can, but additionally theoretically we can go without this support up to this, because this negative pressure and this positive pressure ultimately resultant thrust on the wall become 0. So, that means theoretically at this up to this much depth we can find out we can go without support, excavation without support. This I have discussed during the your discussion theory. So, let me do the steps of calculation here. Here actually you can see that you can PA will be equal to sigma 1 or I can say gamma H Ka minus 2 C root Ka, and where it will be 0. So, that means I get the pressure diagram something like this. So, I find out a depth at which this depth suppose called H naught, suppose this is H naught where pressure is 0. So, if I set 0, then H naught will be coming 2 C by gamma root Ka. But your depth of unsupported cart, excavation suppose is twice of the depth of tension crack. So, that means H will be equal to, that is unsupported excavation, it will be 2 times H naught equal to 4 C by gamma root Ka. So, this is the formula we have to use to find out the depth of excavation without support. Now, since Ka is there, so Ka can be calculated from here. Ka is 20 degrees, so 1 minus sin 20 degrees by 1 plus sin 20 degrees. So, that gives you value 0.3968, approximately you can take 0.4. Okay. So, that means you will get depth of unsupported cart for the given soil will be equal to will be equal to 4 C is 25 divided by gamma is 18 under root 0.4. So, that gives you a value equal to 10.58 meter. So, you can see when you excavate on the sand, then because of the lack of cohesion, absence of cohesion, So, when you cut a vertical cut, then sand will try to flow and make a particular slope, it will never be vertical. But if the soil has some amount of phi, then you can see this is actually vertical cut, we can do up to almost nearly 11 meter. So, this is the beauty in the strength properties of the soil. So, this happens also in the field. So, we apply frequently this type of things in the application. So, this is a second problem. So, let us go to last application, which is a very again simple. You can see a vertical cut in a purely cohesive soil field, when the depth of cut reach to a depth of 5 meter, 5.1 meter. What is the expected value of the cohesion of the soil? So, a pure cohesive soil is mentioned, and its excavation is going on, and suddenly when it reached to 5.1 meter, it failed. So, from here you have to guess based on whatever knowledge we have. Using that, you have to estimate the probable values of cohesion of the soil. So, and it is pure cohesive is mentioned, means phi is absent. So, that is what we have to do here. So, let me see this problem. You know that pressure diagram is something like this. Okay. So, purely cohesive, phi equal to 0. So, that means your K A become 1, that is one thing. And at this point, what will be the value? Actually, this is actually you have P equal to sigma 1 K A minus 2 C root K A. So, this is the one. So, this occurs 0. So, it will be 2 C root K. So, ultimately it will be minus 2 C only at this point. This is 2 C minus, and at this point will be some value, depth is not known. So, we do not know. So, but you can see it failed means up to this you will never fail, as according to our understanding, if you reach at this level it will fail. So, that means this depth is 5.1 meter, and this half of this distance. So, if I do suppose at this depth 5.1 by 2, at that distance your pressure is 0. So, at H equal to 5.1 by 2, your P P will be sorry P A will be equal to 5.1 by 2 into gamma is 20 and minus 2 C root K means 2 C, and we know that at this depth is failure occurred. So, middle of this actually pressure is 0. So, this pressure must be equal to 0. So, if you set this is equal to 0, then from here we can get the C equal to 5.1 into 20 divided by 2 into 4. So, this gives you a value equal to 25.5 kilonewton per meter square. So, this is the problem through proper understanding. I have drawn the pressure diagram and I assume that it failed at this depth. So, at the middle of this the pressure is 0 by using this concept. Otherwise also direct formula, that is depth of unsupported cut, depth of unsupported, or it is a maximum depth actually, maximum depth of unsupported cut, that formula will be equal to 4 C by gamma root K A. This formula is there. So, K A is here 1. So, it is 1. So, if I use that means it will be 4 C by, it is 4 C by gamma. So, that means what it is? 4 C by gamma, and this is actually we have got 5.1. Okay, then C will become 5.1 into gamma is 20 divided by 4 equal to 25.4, 25.5 kilonewton per meter square. So, this is another way, this is directly formula we have used, and whereas here we have just applied the fundamentals. That means, we have drawn the pressure diagram, and then based on that pressure diagram, where we fail, we know it failed at actually double the depth of 0 pressure depth, and from there we have taken that's fundamentally we have done that one, and this one also if you want to use formula for depth of unsupported cord, there k will be 1 and that can be used, and then you will get this value. So, this is the another way this can be solved. So, these are all earth pressure related whatever different kinds of problems are possible, actually all I have covered. Now, I will just summarize that what are the important things we have done here. Basically, you have to know the difference between active, passive and at rest condition. What are they? How they are different from each other? That you have to understand first. That a wall movement, wall when moves towards the away from the backfield, that is active. When at rest, that is K0 pressure or at rest pressure, and when moves towards the backfield, is passive. And this is definitely we can visualize when the wall moves away from the backfield, pressure will be less. So, because of that the least pressure will be active and maximum pressure will be passive. So, these are the qualitative information sometime in memorized type of memory type of problem, that question, that means from the memory you have to answer. So, that type of question if that can be asked, which one is maximum, which is minimum. So, or sometime we will describe wall moves towards this, then what is it is active, passive, or at rest, or none of them. So, that also sometime can be asked. So, you have to get that from this. So, these are the qualitative some information initially you have to know, and then once you get that, next part was your how to find out this active pressure. So, different ways we have discussed Rankine's theory, and we have also described Coulomb's theory. What are the basic difference between these two? The Rankine's theory is a simplified, there is no friction in the wall, and wall surface is vertical and also level backfill. Of course, later on it is extended for sloping backfill, but the important formula actually you have to remember that for Ka equal to 1 minus sin phi by 1 plus sin phi, or in the tan form also tan square, that formula also there, that also we can use, and Kp also will be equal to 1 plus sin phi by 1 minus sin phi. So, from there we can see that Ka equal to 1 by Kp. So, this is also another point to be remembered, and when there is a sloping surface, then the Ka little modified, Ka equal to cos I, and then you have cos I minus under root cos square I minus cos square phi divided by cos I minus under root this is plus. So, this is corresponding Kp also will be here, it will be minus, and this will be plus. This to be remembered, and Coulomb's theory no need to remember, actually it is generally difficult to expect that formula to remember. Only thing, when you do homework there can be some problem, you can refer the equation and do it. Otherwise, important thing is what is the difference between Rankines and Coulomb. These two parts can be studied or remembered. And then second thing was that if the wall face retaining side, actually if it is inclined, then how to use Rankine's theory. So, that we have also discussed, that is if it is a slope is something like this and wall front, then what we do, we can of course, if it is a level backfill, it will not, no change. I have shown one problem. If your wall could be considered as this one and this one, your wall to be considered as this one, and but if it is a sloping backfill, then wall will be considered as this one. So, this difference accordingly everything will be same, only wall height will be changed, and because of that your magnitude of earth pressure will change. So, that is also I have shown one problem. So, that is another aspect, and then third aspect was C phi, soil possessing some amount of cohesion. Then what is PA expression, what is PP expression, and then you know the active earth pressure when when there is a no at a surface, active pressure become negative, and because of the negative pressure there can be a tension crack, and that tension crack depth we can find out. The question can be asked two ways: find out the depth of tension crack, then it will be 2c by gamma root Ka, depth of tension crack. Do not get confused, this is sometimes if it is honestly asked depth of tension crack, because crack will extend up to this, beyond that pressure is 0, just that point pressure is 0. So, because of that when pressure becomes 0, then beyond that it will be positive. So, tension crack will not be there. So, if the depth of tension crack asked, then this is the answer, and if it is asked depth of the unsupported, maximum depth of unsupported excavation, then actually it will be twice of that. So, how it is we have visualized? We have visualized the your pressure diagram is like this, and then this is negative pressure. So, up to this, so because of total of this negative and total of this positive, so become 0. So, that means up to this depth on the wall net effective pressure is 0. So, because of that up to this much depth we can cut without any support. So, this is another. So, there actually you have to do multiply by 2 to get the actual depth. So, this is the way actually we have done all. I hope this is enough and it will be useful for you. Thank you.